All right, number 2, it says the base of a triangle is increasing at a rate of 2 inches per minute, and the height is decreasing at a rate of 1 inch per minute. How fast is the area changing when the base equals 6 inches and the height is 4 inches? So let's go ahead and draw our diagram. We have our triangle with a base and our height. Next, we'll deal with some rates that we know and are trying to find. So the base of the triangle will be dB dt, and that is increasing at a rate of 2, so that's positive 2. And then we know the height is decreasing, so dH over dt is going to be negative 1, because it's decreasing at 1 inch per minute. And we want to know how fast is the area changing. So we want dA over dt. That's what we're looking for. And we want to know this when our base is 6 and our height is 4. So we're going to substitute that in back at the end. So now we need an equation that's going to utilize these rates here. So we need it in terms of B, H, and A. Okay, so we got to have a B, an H, and an A. So what we're going to do is use our area formula. So area is 1/2 base times height. All right, well that looks like an equation with the variables we need. So we need to derive now. So we have the derivative of A with respect to t equals the derivative of the other side, which is 1/2 BH, with respect to t. So now we're going to use our implicit differentiation, and we're going to solve for dA over dt. So we have our constant multiple, and then we're going to use the product rule. First function is b times the derivative of h with respect to t is just dH over dt, and then plus our second function, h, times the derivative of the first. So the derivative of b with respect to t is dB over dt. Now in this case, we have already solved it for dA over dt, which is what we're looking for. So we can go ahead and substitute now. So our dA over dt is going to equal 1/2. Well, we want to know when the base is 6, so we'll substitute 6. dH over dt was negative 1. And then we want to know when the height is 4. And dB over dt is 2. So we just took the rates from here when the lengths are this, and plugged it into our derived equation there. And when we solve for this, we're going to get 1/2 times negative 6 plus 8, which is 1/2 of 2, which is just 1. And so our rate is 1 square inch per minute. So the area of that triangle is increasing at 1 square inch per minute.